joining us at this session on binomial expansion. We're looking predominantly at the C2 module from the Cambridge Mathematics types of questions. And this session we're looking at a question that requires you to expand using binomial expansion. Now here we have the question which asks us to find the first three terms in ascending powers of x. So the powers of x go from small to large. The lowest power of x is x to the power of 0, so we're dealing with the constants first. In this binomial expansion, give each term in its simplest form. Well, a binomial expansion, when it's to the power of 6, you've got the first term, and each one has a coefficient, and you may have understood maybe 6c6, and then this term here, say 2 to the power of 6, and then this term here, which is negative 5x to the power of 0. Now that's the actual first term, and then it's plus. Then what happens is 6c6 could be written this way, or it could be written as 6c6 this way, where it's the first term to the power of 6, the second term to the power of 0. And then the next term, this will drop down to a 5 and this will increase to a 1. So we've got 6c1. What I might do is just, since I've started with 6c6, I might stick with that concept and just say 6c5. And then it's 2 to the power of 5, and it's this term here, including the negative 5x to the power of 1. And that is the second term. This could be written as 6c5 in this format, 2 to the power of 5, and negative 5x to the power of 1. Notice that these powers here, 1 and 5, must add up to 6. Must add up to 6. 0 and 6 must add up to 6. And finally, we're up to just the first three terms. Term 1, term 2, term 3 is 6c4, watch the pattern here, 6c6, 6c5, 6c4, 2 to the power of 4, negative 5x to the power of 2, and that is the third term. This also could be written as 6-4 in a different format, 2 to the power of 4, negative 5x squared. Also, I'd like to mention that this number here must be up here. It has to be either, it can be on either bracket, and there it is there. So that 4 has to be one of these two numbers, yes. And this 6 must be represented as one of those numbers up there. Which really means, you see 6c6 and 6c0 are the same number. So even if we had to put a 6c0 here, it will be the exact same value as 6c6. 6c5 could have been written as 6c1, 6c5 and 6c1 are the same values, because when you look at Pascal's triangle, if you were to look at this triangle for the 6th row, we could use this method to find the numbers. 1, 5, 4 and 6 is 10, 4 and 6 is 10, 4 and 1 is 5. Add the middle numbers, 1 and 5 is 6, 15, 20, 15, 6 and 1. So we've got the 6th row, and 6c6 is 6 factorial over 6 factorial and 0 factorial, which is, and that equals 1. 0 factorial equals 1. And it's the first number, 6c6. So we've got 1, 2 to the power of 6. So I don't make a mistake, 2 to the power of 6. To the power of 6 calculated is 64. You might say, why did I use my calculator? On an exam, you don't want to make silly mistakes. Negative anything to the power of 0 is 1. So our first term will be 64. Our second term, 6c5, You can find 65 by, this is 60, 61, 62, 63, 64, 65, 66. So you could be 6. Well, 65 could be written as 6 factorial over 5 factorial and 1 factorial. That is 6 all the way down to 5 down to 1, which is 5 factorial will cancel here and leave 6. 2 to the power of 5 is 32. Now negative 5x to the power of 1 is negative 5x. So now we just multiply these numbers, 6 times 32 times negative 5, and we get negative 960x. And that is our second term. Now third term is 64, 60, 61, 62, 63, 64. Or you can find 64 by 6 factorial of 4 factorial, 2 factorial. So 6 times 5 times 4 times 3 times 2 times 1. That's a 4 factorial. 4 factorial times 2 factorial. 4 factorials cancel. 30 divided by 2, it's 15. 2 to the power of 4 is 16, and negative 5x squared is a positive number, and that would give us 25x squared. And 25 is 25x squared. So we have 15 times 16 times 25, and we have 6,000 x squared. And we are after each term in its simplest form, and there's the first term. The first term is 64. The second term is negative 960x, and the third term is 6,000 x squared. I'm going to put here plus dot 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 because we have more. There's a fourth term, a fifth term, a sixth term, and a seventh term. We weren't asked for those, so that's all we were asked for. And let's have a look at the solutions here. We've got the first term is simply 2 to the power of 6, and award this when first seen, not 64x to the power of 0. So 64, so we're correct with our 64. Now let's have a look at our next term, and they've said it was, they've used this general formula for the first term is 6c1, and there it is, 6c1 or 6c1. 2 to the power of 6 minus 1 is 5, and we just went straight to the, we wrote just 5, and negative 5x to the power of p, which p is 1, and we don't need the 1 there. These are the other two terms, by the way. That's the second term, and this was the third term. So we're right in saying negative 960x. So we are right in saying negative 960x. And the third term, they've given the calculation for the third term is 15 times 16 times negative 5x squared, which is 25x squared. Notice the positive that they've given us. So we are correct with our 6,000x squared. Okay, so that's a short review on binomial expansion. Have a look at the pattern. Notice the general formula which was used in the solution here, which was 6CP. And then you've got the first term, which was 2, and that's to the power of 6 minus p. It's important that this starts out at the power of 6, because that's when the x value starts off at 0. And if they want it in order of ascending power. You've got to have an extra pair of 0 here. So we will start with a p-value of 0. That would give us a 0 here. That would give us a 6 there. And that would give us a 6C0 here, or a 6C6. Well, actually, I haven't followed the pattern 100%. I simply said that this number here has to be one of those numbers. Slightly different, an alternative option, the way I've selected this value here. But it's important to have a look at formulas and get to know them and see how they apply to this question. All right, well, thank you for joining us on this session. Short and sweet. Until I see you again, stay happy and let us know how you go with any revision if you find questions which are similar to these questions on other past papers.